The uniform distribution is a continuous probability distribution. In this distribution, um, it has equally likely values over the range of all possible outcomes. And that's why we get this rectangular shape to the uniform distribution. There's some notation and properties of the uniform distribution. We will say that x follows u of a comma b, where a is the lowest value of x and b is the highest value of x. The probability density function will be given by f of x is equal to 1 over b minus a. The mean of the probability distribution can be calculated by mu is equal to a plus b divided by 2. The variance will be b minus a squared. We'll divide that by 12. And as always, you take the square root of variance to get the standard deviation. The nice thing about the uniform distribution is that it is a rectangle, so probability will be very easily calculated. It will be the area, which is the base times the height of the rectangle. So, for example, let's say the distribution of arrival times of fire trucks arriving on the scene is uniform with a minimum number of minutes of 2 and the maximum of 15 minutes after being called. So let's define a random variable. X is equal to the number of minutes for a fire truck to arrive on the scene. Scene, S-C-E-N-E, sorry, to arrive on the scene after being called. Excuse me. Okay, so we'll look at our specific problem, and we are told that the minimum number of minutes that it took was 2 minutes, so that is our lowest value of x, and that the maximum number was 15 minutes. This is a uniform distribution. We are told that, so x would follow a uniform distribution of 2, 15. And now we can answer all of these various questions. So let's find the probability density function. We know that that is given as 1 over b minus a. That will be 1 over 15 minus 2, which is equal to 1 over 13. This is our constant line, 1 over 13. The mean of the probability distribution, if it's uniform, is a plus b divided by 2. So in this case, we get 2 plus 15 divided by 2, or 17 halves. The variance sigma squared is given as b minus a squared divided by 12. And just plugging in the numbers, we get 15 minus 2. We'll square that value, divide by 12. That's 13 squared divided by 12, which is 169 divided by 12. And this is approximately 14.08. Lastly, we can find the standard deviation, sigma squared, not sigma squared, just sigma, which is equal to the square root of sigma squared, will be b minus a divided by the square root of 12. So 15 minus 2 divided by the square root of 12. That's the same thing as 13 divided by the square root of 12. And this is approximately 3.72.